Hey, welcome to the Explainer. Today we are pulling back the curtain on something we all use but rarely think about. How is software actually made? From the simplest app on your phone to the most complex systems running our world, there's always a plan. Okay, let's dive right in. Seriously, think about it for a second. How does a tiny spark of an idea, something someone dreams up, eventually turn into that polished, functional app you use every single day? It can feel like magic, but I promise you it's not. It's actually a very carefully planned journey. And just like any big journey, you absolutely need a roadmap. You need a blueprint that guides every single step, making sure you actually end up where you wanted to go, and don't get completely lost in a mess of code and confusion along the way. So, what does this blueprint for code actually look like? What's the plan? Well, let's break it down. The easiest way to think about it is like building a house. You wouldn't just show up with a pile of bricks and start stacking, right? Of course not. You'd start with a design. That's your requirements in the software world. Then an architect draws up a detailed plan. That's the system design. Then comes the actual construction, which is the coding. After that, you have inspections to make sure everything's solid. That's testing. And finally, the best part, you get the keys. That's deployment. See? It's a structured process. And that structured approach has a name. It's called a process model. Basically, it's the formal framework, the official roadmap that brings discipline and predictability to what can be a really chaotic, creative process. It keeps the entire team on the exact same page. So let's start with the classics, the original blueprints. Back in the day, the golden rule was simple. Plan everything out, down to the last detail right from the very beginning. And that brings us to the granddaddy of them all, the waterfall model. It's pretty much what it sounds like. Each phase flows down into the next, and you have to completely finish one step before you can even think about starting the next one. It is a strict, one-way street. No going back. And here are those rigid steps. First, you gather all the requirements. Not some, all of them. Then, you design the entire system. Only after that's done do you write all the code. And then finally, you test the whole thing at the very end. This works pretty well for projects where you know exactly what you need from day one. Think something stable, like a company's internal payroll system. So what's the catch? Well, the waterfall model is incredibly rigid. And in today's world, where things change so fast, having everything perfectly defined up front is, well, it's almost impossible. Imagine you're halfway through building and you realize you misunderstood a key requirement. It's a total disaster. That inflexibility is exactly why people started looking for a better way. And that leads us to the prototyping model. This was a direct answer to Waterfall's biggest weakness. What if you don't know exactly what you want at the start? Well, instead of just guessing, you build a quick and dirty version, a prototype, and you get it in front of actual users as fast as possible. And this right here, this feedback loop, is the whole game. Let's say you're building a new food delivery app. You show an early version to some users, and they immediately say, hey, this is cool, but I really need a way to filter by cuisine. With prototyping, you can add that feature, show it to them again, and keep refining it based on their feedback, all before you spend a ton of time and money building the final product. Okay, but what about the really big, complex, high-stakes projects? I'm talking about banking software or systems for national defense, where one tiny mistake could be a critical, catastrophic failure. For those, we have the spiral model. It basically takes the planning from Waterfall and the feedback loops from prototyping and adds one absolutely crucial ingredient: risk management. As you can see, the whole project evolves in a spiral. Each time you go around the loop, you do four things. You plan the next step, you analyze everything that could possibly go wrong, you engineer a piece of the project, and then you get feedback from the customer. With every single loop, the project gets bigger and more complete, all while you're constantly keeping an eye on and managing potential risks. It's truly built for complexity. All right, let's shift gears because everything we've talked about so far was about trying to control change. Now we're going to talk about a completely different philosophy, one that says embrace change. Welcome to the Agile revolution. See, Agile isn't one specific model so much as it is a mindset, a philosophy. It values flexibility and working closely with the customer above all else. Instead of planning one huge long-term project, you break all the work down into small, bite-sized pieces called sprints, and you deliver a working piece of software every 1 to 4 weeks. But, a mindset is great, but it's a little abstract. You need a practical way to actually put it into action. You need a playbook. And for millions of software teams around the world, that playbook is called Scrum. So if Agile is the philosophy, Scrum is the most popular how-to guide for living it. It gives teams a simple but powerful framework to work in those short cycles, those sprints, and to deliver something of real, tangible value at the end of every single one. And Scrum has a few key parts that make it all work. There are specific roles, like the product owner, who is basically the voice of the customer. There are key artifacts, like the product backlog, which is the master to-do list for the entire project. And there are defined events, like the daily Scrum, which is a quick 15-minute meeting to make sure everyone's on track. It's a whole system designed for focused, rapid progress. But look, building the software quickly is only half the battle. How do you get it into the hands of your users just as fast, without breaking everything in the process? This new challenge led to the next big evolution in how we think about software. And that evolution is called DevOps. It stands for Development and Operations. And the whole idea is to tear down the wall that used to exist between the team that builds the software and the team that has to run and maintain it. It's a cultural shift that's all about collaboration and, most importantly, automation. The ultimate goal of DevOps is something called CI/CD. That's continuous integration and continuous delivery. What that really means is creating a fully automated pipeline where as soon as a developer writes new code, it is automatically built, tested, and shipped to users. Companies like Amazon use this to release new features multiple times a day. It's incredible. Whew. Okay, so we have covered a lot of ground. We've gone from rigid waterfall plans all the way to constant rapid evolution with DevOps. So, with all these different options, how on earth do you know which one to choose? Let's bring it all together. This chart really sums it all up. The truth is, there is no single best model. Waterfall is still great if your requirements are totally stable. Prototyping is perfect for apps where the user interface is everything. Spiral is the heavyweight champion for those massive, risky projects. Agile and Scrum are built for the dynamic, ever-changing world most of us live in. And DevOps is the king for modern, cloud-based software that needs constant updates. And this right here, this is the single most important thing to take away from this entire explainer. These models are just tools in a toolbox. They are not rigid rules you have to follow. You wouldn't use a hammer to drive in a screw, right? The right model is simply the right tool for the job, the one that fits the unique needs, risks, and goals of your specific project. But I'm going to leave you with one final thought to chew on. We've journeyed from these strict, rigid plans to agile sprints to fully automated pipelines. But now, as artificial intelligence gets better and starts writing more and more of its own code, what will the next roadmap even look like? What's the next evolution of building software?